Okay, so we'll are back again. So look in this circuit, right? Then first we have to see that mesh and loop thing, right? So question is that if you look the path A B E F A, that means A B E F A, that means this one, A B E F A, right? This one, right? So this another one is your B C D E B. This is A B E F A, another is B C D E B. So starting from here B C D E B, right? This is actually individual. This is actually mesh. This is a mesh. This is mesh because there is no loop under your what you call and within that. But when you think about loop, then suppose I am making it just it is a blue color. If the color if I can make different color, things would be better. But just try to understand. But if we make like this, like your A B C D E F A, say A B C. Then D, then E, F, A, like this. So this is a loop, A, B, C, D, E, F, A. This is a loop because within this loop, the two more loops are there. So it is a loop, but it mesh means there will be then, but this one and this one, it's a mesh. There is no loop within that. But if you take A, B, C, like A, B, C, D, E, F, A, I mean like this whole thing. If you take like this, so within that there will be another loop here, another loop here. So it's called loop. Right. So this is a slight difference between loop and mesh, but loosely sometimes we talk either loop or mesh, right. But this is the difference between loop and mesh. Okay. So let me clear it, right. So that means if you take just hold on, if you take like this, if you take complete thing like this, it's a loop, right. It's a loop. Suppose you are taking like loop, but within that this is a mesh because then loop when there is no loop within that, right. So this whole thing is a loop, but within that also these two loops are there, so it is a loop. But if you take single this loop, there is no loop within it. Here also there is no loop within it. At the time we call mesh, right. So this is mesh 1, this is mesh 2, and you have this single loop. Hope you have understood the slight difference between mesh and loop, right. So let me clear it, right. So here if you look into the circuit, then this current capital I1 we have taken, this is capital I2 we have taken, and this is capital I3 we have taken, right. And the cyclic current I1 I2 we have taken, this is I1 and this is I2, the cyclic current we have taken, right. So in this case your what you can do is that first you see this I1 current, first you see how things are. This current, this I1 current, for your understanding, it is going like this, right. So this is your I1, right. That means, and this is capital I1. So that means my capital I1 is equal to small I1 here, right. Now if you take this I2, it is going like this, So this I1 if you take, it is coming down, and this I2 if you take, it is going up, this small I1 and small I2. So what will be the I2 then, capital I2, then this is capital I2. So direction is downwards, and this I1 direction is downwards, and this is going upwards. So it is I1 minus I2, this is capital I2, right, is equal to I1 minus I2, and I3 is equal to, this current is actually I2 because it moves like this, right. This is actually I2. That means my small I2 is equal to capital I3. This way, this cyclic current, this way things will be easier for you to understand, right. So now, so that means I1 is equal to small I1 is equal to capital I1, small I2 is equal to capital I3, and in downward direction I2 is equal to actually I1 minus, because I1 moving downwards, so resultant is I1 minus I2 because we have taken a cyclic current, right. So let me clear it. So that means now you apply your, this is your mesh 1, now you apply your KVL in mesh 1, because mesh analysis we have to apply KVL, and nodal analysis we are applying KCL, right. So in this case, but if it is a super node, then of course we have seen KCL and KVL both required. So in this case, if you apply, write down your what you call that your KCL KVL in mesh 1 and mesh 2, then you will get these two equations. I need not write now, but because things are very easily understandable for you. So all this write up is there you can go through it. Whatever I have told, everything is written here, but some places you can find it is written in a book. So please see it in a chapter. There is no such book is completed, right? So if you write your mesh 1 and mesh 2, that your KVL, you will get minus V1 plus R1 I1 plus R2 into I1 minus I2 is equal to 0, right. That means if you simplify, you will get R1 plus R2 I1 minus R2 I2 is equal to V1. That means here, if you apply KCL in this your KVL in this mesh, so it will be I1 R1, right. Then your plus I2 into your I2 into R2 minus V is equal to 0. I2 we have solved, that I1 minus I2. So upon making all these things, this one you will get. Finally, it is coming R1 plus R2 I1 minus R2 I2 is equal to V1. Similarly, you apply KVL to mesh 2, right. You apply your what you call KVL to mesh 2. So if you do so, it will be simply like this: your I3 R3 plus V2 plus your R2 into I2 minus I1, right. So here I3 R3 R2 I2 plus V2 plus R2 into I2 minus I1 is equal to 0. Straightforward you can write, right, because when you are moving in a mesh 2, I2 is upwards, so this you are moving clockwise, and I1 downwards, so I2 minus I1. So understandable. So after that you simplify. This is equation your 24, and then put them in that simple matrix form. So this is your Vy, V1, V2 known. If R1, R2, R3 all are known, so you can solve for I1, I2 the cyclic current, right. And if a small I1, I2 is known, then I1 is equal to capital I1 is equal to small I1 we have seen. Then capital I3 is equal to small I2 we have seen in the diagram, and then I2 is equal to your what you call, in the direction is downwards, so it will be I1 minus I2, right. This is your, this we have seen I1, I have given you I1 is equal to capital I1 is equal to the small I1, capital I2 is equal to I1 minus I2 in the direction downwards as per this diagram, and I3 is equal to I2 as per this diagram. This I2 is the your downward direction, right. So now within this is the mesh analysis. So your what you call that your determine I1, I2, I3 using mesh analysis of the circuit shown in figure your 20, right. So you have to apply your mesh analysis, and that means KVL, this is one mesh, this is another mesh. You apply KVL and accordingly you find out. So only thing is that one voltage source is here. So if you look into that this I1 is going like this, it is going like this, right. So small I1 is equal to capital I1, this I1 you have to find out. Then small I2, this is also going like this, right. So this small I2 also capital I2, right. It is capital I2 because this is your I2 same direction, this is your I1, that small I1 same direction, right. And I3, this capital I3, it is in downwards. So this I1 is downwards, right, and the small I2 upwards. So the resultant is this one, right. So when you solve I1 and I2, then you find out I1 is equal to capital, small I1 is equal to capital I1, small I2 capital I2, and this is I3. So you can now easily apply your KVL. I need not tell much now, right. If you apply for example one equation I am writing, suppose I am moving like this, so plus 10 volt, it is encountering first. So let me clean it, then I will write, right. So if you apply your here your KVL, so it moving like this, so it will be plus 10 because it is encountering your 10 volt first, right. Then it will be your what you call this 10 plus 10 into I1 minus I2 into I1 minus I2, right, because we are moving clockwise. So resultant current here in this branch, in this direction, it is, if you go this way, it is I1 minus I2 moving like this, then encountering minus terminal first of this voltage source, so minus 15, right. Then your plus your 5 I1 is equal to 0, right. So I hope I have not missed anything, right. So, if you simplify, you will get that relationship I1 I2. Similarly, here also same way you do, right. So, let me clear it. So, if you do so, here I have written minus 15 whatever I said, minus 15 plus 5 I1 plus 10 I1 minus I2 is equal to 0. I told you that you write it is plus 10 volt. So, plus 10 is coming, move like this, then 10 into I1 minus I2. So, 10 into I1 minus I2, then you are moving like this. So, minus 15. So, minus 15 is here, then plus 5 I1 is equal to 0. Simplify, 3 I1 minus 2 I2 is equal to 1. This is equation 1. Similarly, for mesh 2, if you apply moving clockwise, so 10 into I2, right, that is your 10 into I2 is here, 10 into I2 is here, plus you are moving this way now, clockwise this way. So, you are moving, I mean you are moving this way now. So, going clockwise this way. So, it will be I2 minus I1 into 10, right. So, make clear it, right. So, it will be 10 into I2 minus I1. So, 10 into I2 minus I1, and then encountering minus terminal first of this 10 volt source. So, minus 10. So, here it is minus 10 is equal to 0, that means I1 minus 2 I2 is equal to minus 1. This is equation 1. So, equation 1 and 2 you solve. If you solve, you will get small I1 is equal to 1 ampere and small I2 is equal to also 1 ampere. Thus, capital I1 is equal to I1, I told you at the beginning it is 1 ampere, I2 is equal to small I2 is 1 ampere, and capital I3 in the direction is downwards, I1 minus I2, that is equal to 0. That means, in that second branch there is no current flowing, right. So, next take another example. Using mesh analysis, determine I in the circuit shown in figure 21. So, you have to find out that I. The question is this one, this is a dependent voltage source, right. This current actually I flowing through this current is I, and this is a dependent voltage source, and you have to your what you call follow the same procedure, right. You have your 1 mesh, 2 mesh and 3 meshes are there. So, accordingly you have to your what you call you have to solve. That means, when you are making in this branch, let me clear it, right. When you are making this branch, right, in this branch. So, this if when you are moving like this, you are moving like this, right. So, this current is your what you call I1. Here it is written everything, but for your understanding, making this your what you call this showing in bigger way, right. So, this current actually, and this current is going like this, and this one going like this, right. So, in this case, if you look into this, so that 5 ohm to the 5 ohm resistance, the current in that I is in the downwards. So, I is equal to actually this I1 is actually I1 minus I2, because I1 is coming downwards and this is going upward, this I2 is going upward. So, it is I is equal to capital I is equal to I1 minus I2, right. Similarly, here in the 6 ohm resistance, when you see that your what is that your voltage drop across 6 ohm resistance, it will be actually, because we have to apply your what you call that your KVL. So, if you apply KVL, then it will be 5 into I, this I. So, 5 into actually I1 minus I2. Then here you have to apply plus 6, the I1 is upward, downward, it is upward. So, it is I1 minus I3, this one. Then encountering negative terminal first, minus 12 is equal to 0. So, you can easily write this equation. This is the first equation for mesh 1. Similarly, for mesh 2, if you apply, if you look into that, move like this, it will be 12 into I2, because 12 into I2, this is mesh 2, 12 into I2, right. You are moving this way. So, this is your I2 and this is your I3, because we are taking clockwise, here also clockwise, moving this way. So, plus 2 into I2 minus I3, right, your plus 5 into I2 minus I1 is equal to 0, right. So, this way you can write all these equations. So, mesh 2. So, let me clear it, right. So, if you come to that, third equation will come later. So, if you come to that first equation I wrote, second equation for mesh 2 also we wrote, right, and if you simplify, it will be 11 I1 minus 5 I2 minus 6 I3 is equal to 12. Similarly, for mesh 2, minus 5 I1 plus 19 I2 minus 2 I3 is equal to 0. This is equation 2. Now, if you come to the third mesh 3, right, we are moving like this, right. So, it will be actually 2 into I3 minus your I2, right. Just hold on. I am telling from my from my mouth, just listen. It will look at the mesh 3. This is your mesh 3, right. It will be 2 into I3 minus I2. We just, if you, I already have able explained, because moving clockwise. So, I3 and in this direction, right. So, I3 minus I2. So, if you look into that, it will be 2 into I3 minus I2. I am telling this term first, 2 into I3 minus I2. Next is your plus this dependent source plus 2I plus 2I means that I is equal to your, earlier I said that I is equal to your I1 minus I2, right, because this is the I, this is I said earlier, and this is 2I, that means 2 I1, the dependent source 2 I1 minus I2. So, plus, if you look into that, plus your 2 your I1 minus I2, here it is, plus 6 into I3 minus I1 plus 6 moving clockwise. So, the current going to taking upward, it is 6 into I3 minus I1. So, plus 6 into I3 minus I1, right. So, this is your plus 6 into I. If you simplify this, it will be I1 plus I2 plus minus 2 I3 is equal to 0. This is equation 3. So, equation 1, 2 and equation 3 you have to solve. If you make it in matrix form and solve any way, Cramer's rule and any way you want, right, you will get I1 is equal to 2.25 ampere, I2 is equal to 0.75 ampere and I3 is equal to 1.5 ampere. Thus, capital I is equal to I1 minus I2. So, it is coming 1.5 ampere, right. So, this is whatever we have seen those problems and little bit of explanation, that is your without any current sources for the mesh analysis. Earlier whatever we saw it is only with the voltage sources. We have not seen any what you call the current sources, right. So, now we will analyze mesh analysis with current sources. So, in this section we will apply mesh analysis to circuit that contain dependent or independent current sources, right. So, presence of current sources in the circuit, it reduces actually the number of equations. So, we have to consider say two following cases. When a current source exists only in one mesh, that is figure I will show you a simple circuit having two meshes, a current source exists in mesh 2, right. So, in this case, suppose this is a current source, there are two meshes and one current source is exists, this is one mesh and this is another mesh, and one current source is simply exists in this. So, if you look into that, right. So, what is the first you have to find out what is the value of I2. So, we have taken like this clockwise. So, we have taken like this, but this 10 ampere it is your upwards, this 10 ampere is upward. So, I2 is equal to minus 10 ampere, that is shown here, I2 is equal to minus 10 ampere. So, number of equation not 2, here number of equation will be 1, because in another mesh a current source is there. So, it reduces the number of equation. So, directly you can write I2 is equal to minus 10 ampere, right. Now, if you apply your KVL in mesh 1, then it will be your, if you look into that, I am writing for you, let me clear it, right. So, if you if you apply your KVL in mesh 1, then it will be 8 into I1, and resultant current flowing in this direction, it is I1, this is going I2. So, it is I1 minus I2 in this direction. So, plus 12 into I1 minus I2, right, and minus 20 is equal to 0, right, but I2 is equal to minus 10 ampere, that we have explained, right. So, if you put I2 is equal to minus 10 ampere, so it will be I1 plus 12 and it is I1, and I2 is equal to minus 10 ampere. So, that means it will be plus 10, right, minus 20 is equal to 0. From here you can find out what is I1, because this is 12, right. So, it is I1. So, from that you can find out what is I1. So, let me clear it, solution is given, right. So, in this case your I1 is equal to minus 5 ampere, this is the answer, right. Now, when a current source exists between two meshes, right, suppose a current source exists between two meshes, so then what will happen? So, just look at the circuit. Look, varieties of examples we have taken such that you should not it should not be any, there should not be any confusion. AC circuit also similar thing will be there, but we will take less number of example when we will see that, because complex number is involved, it takes time to solve, right, but concept will remain same. So, question is that whenever you have there are two meshes, in between, look, a current source is there, and along with that one 4 ohm resistance also there is in series with this current source, right. So, what you can do is, so let me clear it. So, what you can do is exclude these elements. Exclude these elements means that we create a super mesh by excluding the current source and other elements connected in series with it, as shown in figure this, right. So, exclude these elements because we are by excluding this we are creating a super mesh, like super node we have studied. Now, we will create a super mesh. So, in this case what will happen, by excluding the current source and the other elements, it is shown in that this a super mesh is created, right, but it is your what you call, this current is I1, this current is I2, right, but do not consider as same current 12 and 28 ohm this is flowing, no, not like that. So, a super mesh is created. So, now in this case you apply your what you call the KVL, then it will be 12 into I1 plus 20 into I2 minus 40 will be is equal to 0. Look, 12 I1 plus 20 I2 minus 40 is equal to 0, because this super mesh is created and you exclude this, right. In other way if it is there, in other way basically you are applying KVL in this loop, right. So, if you apply KVL in this loop, then it is basically 12 I1, this one 12 I1, then here also plus 12 I2, 28 I2 and minus 40, because encountering negative is equal to 0. So, basically you are just keeping this one, you exclude this one, the super node is created, exclude this one. So, this way same way we are writing, right. Let me clear it, right. Let me clear it. So, this is your I1 and this is super mesh is created this way, same equation I showed you how to write. So, this is your if you simplify 3 I1 plus 7 I2 is equal to 10. Apply KCL to node O in figure 3 gives this one. Now, second thing is you apply KCL at node O, that means let me this thing, this is your node O, right, it is O. So, question is that here the 6 ampere current, actually this is upward direction. So, this is 6 ampere, it is leaving the node, and this I2 is actually entering into the node, and this I1 is leaving, because current I1 goes like this, current I2 also goes like this, right, goes like this, right. So, basically this I2 is entering at this node. So, I2 is equal to your 6 plus your I1, right. So, KCL you apply at this node, right. So, let me clear it. So, that is why we have written here that I1 plus 6 is equal to I1 is equal to I2 minus 6. Now, solve this equation 1 and 2. If you solve, you will get I1 is equal to minus 3.2 ampere and I2 is equal to 2.8 ampere. Therefore, a super mesh has the following properties. One is, a super mesh has no current of its own, right. This is your this is the first thing, a super mesh has no current of its own. Second one is, the current source in the super mesh provides the constant equation necessary to solve for the mesh current. So, which is constant equation? Let me clear it. So, here, because this is actually this equation, actually your constant equation, this equation, this equation is your constant equation, this equation, because we apply KCL at node O, because that is why it is a constant equation, otherwise you cannot solve it, right. So, whenever you are excluding the super mesh, then you have to think that one your KCL has I have to apply to get that other equation, then only I can solve it, because using that loop or super mesh concept I got one equation. So, and another thing is, in the super mesh you have to apply KCL, and that is applied, and this is the constant equation, right. Let me clear it. And third one is a super mesh requires the application of both KVL and KCL, because like your nodal analysis also we have seen super node KVL and KCL, here also KVL is required, at the same time the constant equation here is KCL, right, that is must, right. So, take another example, this is a bigger one. Determine I1 and I4 using mesh analysis of the circuit shown in figure this, right. So, in this case what you can see is, first look at the problem. This is one mesh and this is another mesh, this is another mesh, this is another mesh. There are 4 meshes. Between these 2 meshes, one your what you call that current source is there, and right. Therefore, as we saw previously, 2 meshes are there and in between your current source is there. So, it creates a super mesh, right. Similarly, between this mesh and this mesh another dependent current source is there. This is independent current source, this is also creating another super mesh. So, this super mesh and this super mesh they intersect, right. Finally, they created this super mesh. So, let me clear it, right. So, ultimately this whatever is there, so they have a common dependent current. So, I told you intersect, and this actually finally it is a bigger or larger super mesh. So, ultimately this is, I to repeat again, this is a current source between this mesh and this mesh creating a super mesh. Also this is another mesh, this is another mesh, a dependent current source is there, it is independent creating another super mesh. So, these 2 super meshes intersect each other, and finally the dashed line this creating your what you call larger super mesh, right. Based on that we have to apply, right, we have to solve this circuit. So, hope you have understood this, right. So, dashed line is actually larger super mesh. So, here if you see all write up is there, whatever I am telling all write up is there. When you listen to this you pause it and just note it down, right, if you have anything. So, now applying KVL to the larger super mesh you will get. So, this larger super mesh you apply KVL, this is 4 I1, this is 4 I1 plus this is your 8 I3, right, and plus this is your 12 I2, right. If you look into that is equal to your 0, right. 4 I1 one thing I have missed, 12 I2, 8 I3, 4 I1, another one I have missed, right. That is your this 16 is here, 16 I3 minus I4, because it is we are moving like this, 16 I3 minus I4, because we are moving clockwise, we are moving in the super mesh, right, we are moving like this, right. So, 16 I3 minus I4 here it is coming is equal to 0. So, let me clear it, right. So, this is one equation you got, right. So, upon simplification I1 plus 3 I2 plus 6 I3 minus 4 I4 is equal to 0. For the independent current source we apply KCL to node A. So, if you apply KCL here, at node A you apply KCL here, right. So, this if you think that this I2 your is equal to I1 plus 5, because this current is entering on I1 and 5 ampere, this 5 ampere current source. So, leaving, so it is I1 is equal to I2 plus 5, right. So, just hold on. So, this is you are applying KCL at node A. So, if you apply KCL at node A you get I2 is equal to I1 plus 5. I told you for the dependent current source we apply KCL to node B. So, for dependent current source this is another node is here, right, another node is here, right. So, for dependent current source we apply KCL at node B. In this case what will happen, that this current your what you call this is a dependent current, this is actually I and this is actually 3I, this is a dependent current source, right. So, if you apply then your KCL at this point, earlier we have applied here, now you apply KCL at this thing, then this current actually entering this I3, right, and this 3I current also coming here, these two are entering, plus 3I is equal to your what you call I2, right. So, that means if you let me so I3 plus 3I is equal, and this I actually here it is a dependent, or what you call dependent current source, right. So, another thing is that this I3 actually moving like this, right. So, basically your what you call but anyway we are applying this one, later I will come to that. So, applying your I3 plus 3I is equal to I2. So, let me clear and go back to that equation at KCL at node B, right. So, where it has gone here, that I2 is equal to I3 plus 3I, right. Now, you have to see that what is your I4 is equal to minus I. Next one is here, if you come, this direction we have taken, just hold on, this direction we have taken. So, this is your I4, but this I is taken upward going like this. So, I4 is equal to minus I, or capital I is equal to minus I4, right. So, let me clear it. So, this one this one I, then I2 is equal to I3 minus 3I4, right, because just now we have given that I is equal to minus I4. This is equation 3. Now, apply KVL in mesh 4. If you apply KVL in mesh 4 in this mesh, that means in this mesh if you apply KVL in this mesh, if you apply, it will be 4I4 plus 20, right, plus 16 into I4 minus I3. So, let me clear it. So, directly I am not writing again, it is understandable to you, right. So, if you apply your this thing 4I4 plus 20 plus 16 into I4 minus I3. So, this is 5I4 minus 4I3 is equal to, so equation 4. So, you have 4 equations and 4 unknown. So, after solving this, you will get I1 is equal to minus 7.5 ampere, I2 is equal to minus 2.5 ampere, I3 is equal to 3.93 ampere, I4 is equal to 2.143 ampere. So, this is 4 unknown, but all 4 equations are simple one, and I do believe that you have understood that, because with the time we will progress. So, initially everything I am writing for you for your understanding, and after that little bit you also do, right, and I believe all these answers, everything computed here are correct. And if by chance if you find any calculation or anything, so just send me an email when you will read this your video lecture. Thank you very much. We will be back.